All right, AP Physics 1, I'm going to do a demonstration, so hopefully it works. We'll see how it goes. But the principle I want to look at today is beats. So this is the term that physicists use to describe that characteristic when you have two very, very closely matched frequencies that are not quite the same frequency. And you'll get constructive and destructive interference that happens, but it won't be always the troughs and crests lining up, because they'll be shifted from one another just a little bit. And so you'll get a kind of weird looking pattern like this when you're dealing with beats. And notice that you've got an oscillation here inside of a larger oscillation. It'll sound kind of like a wah 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 sound is happening, which I know it probably sounds funny when I say it and make that sound, but hopefully we'll be able to actually observe it here in just a second. So let's see. Here's what I have for you. I have some speakers set up. You can see I've got several different speakers. Two of those speakers are connected to one of our CPO timers, and one of them is set up and connected to another one. And what I'm going to do is, first of all, direct these speakers towards my phone a little bit more. I'm going to turn the volumes up here. So you can hopefully hear. Actually, before I do that, let me just explain what I'm going to do. I'm going to turn up the volumes, and they're both going to be playing the same frequency. So you should hear the same pitch from both. But I'm going to change the frequencies of one of them so that you can start to hear the beats in that sound. So let me put this back here, put the volume up. Okay, so what I did was I brought those sounds really far away from one another, and then I brought the frequencies back close again so you could hear it come back into tune. So basically, beat frequency, so how fast you hear those oscillations, actually depends on how far apart those different frequencies, the two frequencies you're playing, are from one another. So the closer the two frequencies are to one another, the longer those oscillations will sound like they are. And as two notes get further and further out of tune from one another, you're going to hear faster oscillations. So I'm going to do this again really quick, and I'm going to play these two notes, and I'm going to bring them further out of tune. Let's see, I'm trying to figure out, maybe that's the right way to do it. Okay, so And I think one of the most important things that I'd like you to take away from this, other than like the fact that these speakers are really, really annoying sounding, is that this is evidence that sound is a wave. So we can't see the air molecules oscillating back and forth, but we can observe the effects of the air molecules oscillating and hearing that constructive and destructive interference that happens with sound waves when we make them overlap.